We are FLL Team 12891, the Electric Mayhem from Buffalo, New York.
For our project, we want to address the question of where colonists on Mars would live. We know that it costs about $10,000 per pound to put objects in space. A building the size of a large camper would cost about $50 million to get off the Earth. Not too many people could live in there. We don't think it makes sense to carry the buildings themselves to space. We think it would make more sense to bring a machine to Mars that could build as many buildings as the colonists would need. Our research was focused on how we could achieve this goal. Here are the ideas that we found that really excited us.
There are a few companies in China that have been successfully 3D printing entire buildings out of concrete. There are several good YouTube videos that show this process. A giant robotic arm is programmed with a tool path based on the CAD file for the building. Concrete is pumped through the extruder. An 800 square foot, one-story building can be fully printed in a single day.
Lorena James, a student that graduated from Nichols High School in 2016, came up with an idea to create 3D printer filament from the shells of the zebra mussels that have invaded the Great Lakes. She has created a startup company called Z-Spools that harvests zebra mussels and creates calcium-based printer filament that can work in a printer. Lorena is currently living in China, and our team did a video conference with her to ask about how she thought of her process and how it works, and whether or not she thought of something like it could be used for our potential Martian constructions.
Much of the Martian surface is covered in sand. Can we use the sand to build from? We found a guy on YouTube named Marcus Kaiser. He has an invention called the Solar Center Project. He has created a large 3D printer that uses sand as the building material. He uses a set of 4 large Fresnel lenses to focus sunlight onto a pan of sand. Wherever the light strikes, the sand melts into glass. The pan is moved by a set of stepper motors that are controlled by a toolpath based on the CAD file of the designed object. There is a lot of sand on Mars, and it is not very different than the sand we have here on Earth. It is mostly silicon dioxide. One important difference between Earth and Mars is that Mars is farther from the sun, and therefore it gets about 40% less solar energy than we do. On Earth, we get a peak value of about 1,000 watts per square meter, and on Mars, the peak value is just under 600 watts per square meter. We can use solar energy on Mars, but we would need 40% more solar panels to get the same energy output that we need on Earth.
We looked for answers to some of our material science questions from the Corning Company. We wrote them a letter and got a very detailed response from them about our ideas. They think that it is unlikely that we can make glass pure enough and strong enough to be useful as a building material on Mars. However, they do think that we can make Fresnel lenses big enough and flexible enough to collect and use solar energy on Mars. They also think that there is enough water on Mars to use traditional concrete for our buildings.
There's a lot of carbon in the atmosphere, and there's a lot of hydrogen in the soil on Mars. Those two elements can be combined to form a polymer resin. If we could harvest the carbon and hydrogen, we could make a resin concrete that would use Martian rocks as aggregate and the resin as a binder to build our structures.
The great thing about the 3D printers that we own at school is that we can draw something complicated, put the CAD file into the printer and walk away. When we come back the next day, the object exists. But the 3D printer is a controlled environment. The extruder knows exactly where the print bed is at all times. Can a robot build reliably in a less constrained environment? We found a video on YouTube that shows a swarm of drones that pick up foam bricks from one room and fly to another room where they cooperatively build a castle based on a shared CAD file of the project. There are transponders in the room that act as a miniature GPS constellation so that the drones know where they are in space.
We have combined all of the ideas from our research into a final design for our colony construction concept. We want to make a large-scale autonomous vehicle that we will send to Mars to construct a camp before we send the colonists. The robot will be pre-programmed with the CAD files it needs to construct living quarters, common areas, labs, storage bays, and garages. Here's what our vehicle would look like. It has big tires and jointed axles to be able to handle rough terrain. It has a bulldozer on the front to flatten out the area where we will build our colony. The robot will deploy a set of transponder beacons that will mark the locations for each of the buildings and serve as coordinate references for the robot activity. The robot will have sensor arrays that will include a LiDAR system to detect obstacles. Another receiver will gather live coordinates from the transponder beacons.
The vehicle will run off solar energy. We'll have sensors and solar panels that will keep it aimed to the sun at all time to gather maximum amounts of energy. There will be a large capacitor banks under the vehicle to store the energy we gather. The vehicle will vacuum sand and rocks to be used as aggregate material in the concrete. We will then mix the material into the resin binding material.
The robot will be launched from Earth in a rocket. The capsule will then take about 9 months to get to Mars. When it gets there, the capsule will land and deploy the robot. The first thing that the robot will do is level the chosen site for the colony. After that, it will deploy the transponder beacons. Each beacon will become the center of a building. The robot will drive around the outside of the camp perimeter to gather the raw materials it needs to build the structures. The robot will then start construction. It will use the beacons to keep track of its location when it is building. It will gather more resources when it needs to. After a few weeks, we will have all the building we need. When the colonists land, they will just add the doors and windows and furnishings of the buildings. The robot can keep building new buildings to expand the colony over time. For the price of putting one RV on Mars, you can put a machine capable of building a whole town.